So here's where I'd like to start. We talked about canceling factors in simplifying, or fraction, rational expressions. We talked about multiplying and dividing rational expressions. So now we're going to talk about combining them, which means adding and subtracting. So when we refer to the adding and subtracting, let me go through again an example as I talk through the steps. First step is you're going to factor the denominators of all the fractions that are being added or subtracted. Okay, so in this particular example, I don't need to do that step. There are no other factors for it. Step 2, you're going to find the LCD. LCD represents least common denominator, and the way that you find that is we're going to write a single fraction with the LCD as the denominator. Okay, and so the way that you're going to find that is we just create our single fraction, and you find every distinct or unique factor in the denominators of all the fractions involved. So here's a distinct factor. We haven't had anything yet. We haven't written anything down here. So we write x minus 3 as one factor, one LCD factor. Here's another distinct factor. It's not already written in the LCD. And so here it winds up being the LCD is just both of the factors in the denominator. Okay, so this is the LCD. This is going to be the denominator of the fraction that we combined into the single fraction, the combination of these two expressions. Okay. The next step is to combine the numerators. Into one expression. And this is the step that often causes the confusion. The way that I suggest that you go about doing this is begin with the terms that were already in the original expressions. So x, leave a space, plus 2. So in purple right here, all I've done is rewritten what the original numerators, the terms in the numerator were. Now, the way that I would suggest that you combine these is multiply each of these terms in the numerator by the LCD factors that we're missing from the individual fractions denominator. Okay, so here's what I mean by this. Okay, we take the original numerator and we multiply it by what LCD factor, so which of these two factors was missing from this original fractions denominator? It's missing the 3x plus 4. Okay, plus 2, the next fraction's numerator, times what factor, which LCD factor was missing from this fraction's denominator? Okay, and so this is how you can combine these into one single expression. And now you just simplify. So when we go through this step, our last thing is to simplify, factor, cancel any common factors, all of this stuff that we've already done in the previous sections. So when we distribute here, we get a 3x squared plus a 4x, distribute the 2, plus a 2x, minus a 6. Notice I'm just working in the numerator here, so I aligned all my terms vertically, just to make it easier to combine. And so here's my new numerator, written as a single expression. And then I'm going to write this over my denominator, which is just the LCD factors. Okay, so my final step is to simplify, which I just did. Factor. Is there anything that you can factor out of this numerator? Take out a 3. When you take out a 3, you're left with x squared plus 2x minus 2. And then the denominator, again, is just going to stay as it is. Can you factor this trinomial any further? Are there two factors of negative 2 whose sum is positive 2? No. So this is as simplified as it gets, and that would be your solution. Okay. Now, does it matter which terms are written, or which factors are written first? Here is my suggestion for writing factors. It's what you're usually going to see. And that is monomial factors will be written before binomial factors, which will be written before trinomial factors. So that explains why the 3, I wrote the 3 in front of this. Here, these are two binomials, so it doesn't matter which order you write them in. Okay. All right, let's take another example. I want to talk through the different steps, and then I'll give you one to do on your own. All right, here's one that involves both adding and subtracting. Okay, when you look to combine these fractions, again, step 1 is factor all the denominators. So already factored. What does x squared minus 1 factor into? X plus 1, x minus 1. So we're going to look at the factored form of this. Okay, step 2, we're going to rewrite this as a single fraction using your LCD. So here's one LCD factor, x minus 1. A second distinct LCD factor, x plus 1. And here we have two more factors, but are they distinct? No, we already have the x plus 1 and we already have the x minus 1. So here's our LCD. We don't need to repeat factors unless they happen to be repeated in the denominator, meaning if this had been x plus 1 squared or x minus 1 squared, we would need to put another one here. But this is our LCD. We're going to take the term, the first term, or the numerator of our first term, 2, and we're going to multiply that by any LCD factor that's missing from its denominator. Which of these LCD factors was missing from this fraction's denominator? X plus 1. Keep the next term, numerator the same, plus 3 times what LCD factor was missing from this denominator? X minus 1. And then keep the next fraction's numerator the same. Notice I put it in parentheses, especially because this negative means you're going to distribute that through. But we're going to multiply that by any LCD factor missing from its denominator. It's not missing anything. So you don't have to write a 1 here. I'm just writing it there to color code it and show that there's nothing that you have to add to that factor. Okay, my next step is to simplify my numerator. So I'm going to distribute my 2 through. 2x plus 2. Distribute my 3 plus 3x minus 3. Now I'm going to distribute my negative. Negative 4x minus a negative becomes a positive x squared. So again, I aligned all my terms vertically with like terms just to make it easier to combine. And as I write this down, I get an x squared. I have a positive 1x, and I have a minus 1. So there's my simplified numerator. My denominator is going to stay this set of factors just as it was. Okay, can I factor this numerator any further? Any factors of negative 1 whose sum is positive 1? No. Let's see if you can simplify this expression, please. This is sample problem 5A on page 33. All right, let's take a look at this problem. So once again, step 1, factor it. The denominators are already factored. So we can jump to step 2. Step 2 is combine into a single fraction. So we have to have a factor of x plus h and a factor of x. Now, here's where just that ordering comes into play. Since the monomial factor, I'll put it first. Again, it goes monomial, then binomial, then trinomial, and so on. Okay, so here are my two distinct factors, my LCD. Now, I go to the numerator of my first fraction, and I'm going to multiply that by the LCD factor that's missing from its denominator. What's missing from this fraction's denominator? X. Okay, minus the next fraction's numerator, 1, times what LCD factor is missing from this denominator? X plus h. So now I can simplify my numerator. Okay, multiply and get x, distribute my negative, so minus x minus h. And that's all over x times x plus h. The x and negative x cancel. And it leaves my solution, negative h over x times x plus h.